outline about a project titled Risk Analysis on Genetic Diseases Using Machine Learning. Genetic disorders present substantial obstacles to both the public health and the personal health due to their intricate hereditary nature and the potential to cause the grave medical issues. The conventional evaluation of the risk in genetic condition has traditionally depended on the statistical technique and genetic assessment. The shift strides in the field of machine learning and artificial intelligence offer an unparalleled chance to transform the tackle risk assessment in this realm. This research seeks to investigate the capacity of the machine learning methods to forecast and evaluate the likelihood of genetic disease, thereby potentially facilitating the early detection, tailored therapeutic approach, and preventive action. By harnessing this cutting edge technology, we significantly enhance our understanding and management of genetic disorder. The core aim of this study is to create a robust and precise risk assessment framework employing the machine learning algorithm to foresee the susceptibility to genetic disorder in the individuals. Firstly, the compilation of the comprehensive and the varied data set containing the genetic data, medical histories, and the clinical information from the diverse sources, and the identification of pertinent and the informative features from this data set that can be substantially impact the likelihood of genetic disease manifestation. The implementation and comparison of various machine learning algorithms such as decision-tree, random forest, support vector machine, and the neural networks to ascertain the most efficacious model for the risk evaluation. Subsequent to the algorithm development, the model's effectiveness will be gauged through the metrics like accuracy, precision, recall, and FM score, ensuring the robust prediction. Moreover, efforts will be directed towards enhancing the model interpretability, shedding light on the factors contributing to the genetic disease risk. Lastly, the feasibility of the real-world application in the healthcare scenarios, particularly in personalized medicine and the genetic counseling, will be explored to realize the practical benefit. And these are the basic requirements that are needed to build this project. The software requirements are Python IDEL with version of 3.7, Anaconda with version of 3.7, or Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the packages. In this step, essential libraries and packages are imported into the programming environment. These libraries such as sklearn, pandas, numpy, and matplotlib provide the foundation for data manipulation, visualization, and the implementation of the machine learning algorithm. And the second one is exploring the dataset. The genetic disease dataset is examined to gain the insight into its structure, content, and the potential challenges. And the next step is data processing. Data pre-processing is crucial for ensuring the dataset is suitable for training the machine learning model. This step involves handling the missing data through imputation, dealing with outliers, and addressing the data inconsistencies. Pre-processing also includes transforming the categorical data into the numerical format through the technique like one-hot encoding or the label encoding. And the next one is visualization using the Seaborn and the Matplotlib. Data visualization using the libraries like Seaborn and the Matplotlib help to uncover the pattern, trends, and the relationship within the dataset. And the next step is label encoding. Label encoding is a technique used to convert the categorical variable into the numerical value. This process assigns the unique integers to the different categories, enabling the machine learning algorithm to process the data effectively. And the next step is feature selection. Feature selection involves identifying the most relevant and the influential feature from the dataset that contribute significantly to predicting the genetic disease risk. This helps in reducing the dimensionality and improving the efficiency of the model. And the next step is building the model. Various models are built. The first one is random forest. It is an ensemble learning algorithm that combines the multiple decision tree to make the accurate prediction. In this project, random forest is employed to predict the likelihood of the genetic disease. The algorithm works by constructing a multitude of the decision tree during the training phase. Each tree is trained on the different subset of the data and makes its prediction. In the case of risk analysis for the genetic disease, random forests B captured the complex interaction between the various genetic and the medical features, providing a robust prediction model. Its ability to handle the high dimensional data and mitigate the overfitting makes it suitable for this application. And the next one is decision tree. It is a fundamental machine learning algorithm used for the classification task. In the context of this project, a decision tree can create the structured flowchart like model that assess the different genetic and the medical features step by step to arrive at the prediction. Each internal node of the tree represents a decision based on the feature, and each leaf node represents a predicted outcome. Decision trees are interpretable, making them valuable for understanding the factor contributing to the risk prediction. And the next one is PCA-KNN. It stands for Principal Component Analysis with K nearest neighbor. It is a hybrid approach that combines the principal component analysis with dimensionality reduction and the K nearest algorithm for classification. In the project, PCA is used to reduce the complexity of the genetic and the medical feature space, while KNN leverages the reduced dimension to classify the risk of genetic disease. By reducing the dimensionality, PCA-KNN can address the multi-collinearity among the features and improve the efficiency of the KNN algorithm. And the next one is naive-Bayes. Naive-Bayes is a probabilistic classification algorithm based on the Bayes theorem. It assumes that the features are independent of each other, which not hold true for all the cases. In the context of genetic disease, naive-Bayes B still provide the valuable insight. And the next one is user gives the input. Here we used the Flask as a web framework for the interface to the user, where the user provides the input, which could be the information about the genetic markers, history, and the other relevant factors. And the next one is the given input is pre-processed for prediction. The input data is processed to ensure the consistency and the compatibility with the trained model. And the next one is trained model is used for the prediction. The pre-processed input is fed into the trained machine learning model, which then generates the prediction about the likelihood of the genetic disease based on the input feature. And the last one is final outcome is displayed. The prediction from the different models are aggregated individually depending on the approach chosen. The final outcome is displayed to the user, providing the information about the predicted risk of genetic disease based on the input provided. And the execution of the project. To execute the project, first we need to open the code folder. And this is the code folder containing of various files within it. The static folder containing of CSS, fonts, JSS, and assets files within it. And the template folder containing of the HTML documents. It typically include of home, index, notebook, results, sign-in, and sign-up pages within it. And the app is an py file which likely contain the information related to the front-end logic. It includes the code written in Python that handle the server-side operation such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the GUO is the CSV file that we used in this project as of the dataset. And the model is the SCAV file which contains the algorithm information, and it is used in the project code during the runtime to utilize the trained model for the various tasks, such as making the prediction on the new data or performing a specific operation. And the notebook is an IPYNB file which contains the combination of code, graph, and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And the processed is a CSV file that will be created after the processing step. And the signup.db is a file appear to be the database file used to store the user information. And for the execution of the project, first we need to copy this code folder path and then open the Anaconda prompt. Here we need to write a command cd space and paste this code folder path. By this it will change the current directory to the code folder path. And then click on the enter button. Here we need to write a command that is python space app.py. By using this command, it will execute the Python script and perform the runtime check for any syntax errors or logical issues. and then click on the enter button. After running this app.py file, the Flash framework will host the application locally at the default address like this. We need to copy this link and paste it on any of the web browser of our choice, and I prefer to use Google Chrome. I'm pasting this link and then click on enter button. Here it will be redirected to this page containing of some info and of the title of the project. And I'm clicking on the sign up button. Here it will redirect to the sign up page containing of some details that are need to be filled to create an account. But my account is already created, that's why I'm using the sign in button. Here it redirect to the sign in page containing of username and password, and we need to fill those details. And then click on the login button. Here it will redirect it to this page containing of some input details that are need to be filled. And here we need to enter those details. Enter the DSI as of 0.564 and enter the DPI as 0.724 and the disease name as of depressive disorder and the disease type as disease, and the disease class is F03, and the disease semantic type is mental or behavioral dysfunction, and the score is 0.31, and the E1 is of 1, and gene description is of alpha 2 microglobin, and the disease class name is of conjunctional hereditary and neonatal disease and abnormalities, mental disorders, substance related disorder. And then click on the submit button. Here it redirected to this result page. Based on the input, the patient is affected with the depressive disorders. In this way, we can analyze the risk of genetic diseases using the machine learning. And in conclusion, the study demonstrated the potential of machine learning in enhancing the risk analysis for genetic diseases. Through the implementation of various algorithms and comprehensive data analysis, we have shown that machine learning models can accurately predict an individual's risk of developing the genetic disease based on their genetic information and the medical history. The result of this research highlight the importance of the feature selection and the model optimization to achieve the accurate and reliable prediction. Moreover, the interpretability of the models allow the clinicians and the genetic counselors to better understand the underlying factors contributing to the risk, enabling the personalized medical intervention and the preventive measures.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.